I wake up every day going to the lab because a student might have made a discovery or an observation, and I love it. I grew up in Amman, Jordan. I was born and raised in Amman, Jordan. And I was born to a refugee family of, well, we were all 10 kids, and and plus our parents. And we lived in a humble home. We didn't have the usual conveniences of running water or electricity. And in addition to that, we also shared the space with our livestock that we lived off. So it was I would say it was not an easy childhood. And my parents worked very hard to send us to these nice, strong schools in Jordan. And so I went to really good schools as a kid. And the interesting thing about my childhood is that my father's shop, he had a butchery shop, right? And it was between where we lived and the school. And so every day we walked from the home to the shop, and if we hadn't had breakfast, my father would make breakfast at the shop, and then we would go to school, and on the way back, we would pass by the shop and on to home. Now, the reason I mentioned the shop is because it was very important in my life. I would help my father with the different chores around the shop, and there I learned that when you do a job, you have to do it well and you have to do it completely. And so if it was cleaning something or another and I didn't do a good job, he would tell me to do it again and again and again until it was done properly. And there I think I learned work ethic, the importance of having excellent work ethic. So that was, I think, figured prominently in my teaching as a child. So I understood that part. I understood that you have to always tell the truth, always aim high, and to try to open up your own path rather than just following others' footsteps blindly. That you need to figure out how to do your own thing. So I learned a little bit of independence there. At home, I was part of a larger family, very rowdy, and many kids, many boys, okay? And but I didn't play with them. I didn't play the games that they were playing, whether it's, playing with a soccer or whatever. I was not involved in that. It seems that most of my childhood was spent in a corner doing my lessons and just observing what was happening around me. So I was a very quiet child. In fact, I didn't like talking to anybody growing up, to the point that I told my parents in 3rd grade not to talk to me at all about my grades. And in fact, I refused to show them my marks that this school would send with me every month. So I thought it was a matter of pride that they should trust me and trust that I'm doing well. So I think they detected that was okay, and it was not a problem. There was another aspect of my childhood that again became very important later in my life, and that was when I went into this library and I saw molecular drawings. I didn't know they were molecular drawings, but somehow they captivated me. In fact, I kept them secret for a while because I thought I've discovered something that potentially nobody else discovered. And so when I learned there were molecules, I was, and that molecules make up everything around us, living and non-living. Well, how could you tear away yourself from such an endeavor? And so that's how I got interested in chemistry. I must say that school to me was not a pleasant place, not because I was mistreated in any way, but I just thought structured learning was not my thing. I learned everything that I know from books, from reading the text, reading other books, and things like that. I wouldn't say that I was influenced in any way as a child from a particular teacher, although, you know, I've taught a lot of students, and many of them explained to me later that they were influenced by a teacher they had in high school or when they started doing science, became interested in science. So no, I mean, I think where teachers were influential with me was in graduate school with my PhD mentor. I was a sort of a loner as a child, and I enjoyed being alone. I enjoyed learning alone, and of course later on in life I realized that talking to other people is also very important in opening up the mind. So, but that served me very well, I think, growing up. On one of these trips to my father's shop from the school, he said, "You're going to America." And I said, no, I'm not going to go to America. I want to stay here, finish high school here, and finish college here. And he insisted that that was what I'm going to do next. And I was only in 9th grade. So I went to the embassy, American embassy, and there I stood in line for, you know, every day for a couple of weeks until I got to go in. And they asked me a whole bunch of questions, and I said, I want to immigrate to the US and I want to study. And they said, okay, well, how much savings does your family have? And I said, well, I think I know how much because I keep track of this. It's about $9,000. And they said, okay, well, tomorrow, come in with a check for $9,000 in your name, so that you can take it to America and you can support yourself in America. And so I thought, oh my God, what is my father going to say? So I went down to the shop and I informed my father, and he said, okay, go to the bank and get it, without hesitation. And I think that tells you how committed my parents were. I'm sure this is a story that repeats itself in many families where the parents are absolutely dedicated to their children's education, because education is the gateway to better life and potentially happiness. Well, I think science, I said science is the greatest equalizing force in the world because anyone, regardless of their background, regardless of their gender, regardless of their academic standing, regardless of their economic standing in society. So anyone can go into a lab and potentially make a discovery. And that discovery can change the world. And that's why science, there's no other discipline, as far as I can tell, where this transformation could happen so quickly. Where a small discovery made by a humble researcher takes you from an unknown into the sky. That's the power of science. And in so doing, you're transforming yourself, you're transforming, depending on the discovery, the world around you. So I think that's one aspect of science that I really love. The other aspect is that the more mixing in science, more mixing of people with different backgrounds, with different way of solving problems, mixing talent from all around the world, creates innovative atmosphere, the atmosphere of discussion and critique and debate about different points. And you make an observation in a laboratory and you question that observation. You debate with other people what it might mean. And everybody is different, who comes from different parts of the world, thinks differently. This heterogenization is the magic of doing science. And it turns an experience where you are constantly failing in the lab, or we call it increments of success, it turns into an enjoyable experience. Well, I think it's the thrill of discovery. I think we do science because We want to stimulate our mind. We also want recognition for our work. I think those two things are very important. But then beyond that, you want to do it to impact others. And so discovery is the currency of influencing people's way of thinking, of changing people's lives to the better, impacting society in ways that were unprecedented before that discovery. So discovery is everything. It's a thrill to me. I'm addicted to it. I wake up every day going to the lab because a student might have made a discovery or an observation may lead to a great discovery. It's still in me and I love it. And I would never give it up for anything. Well, today I've been awarded the Nobel Prize, right? And for many people, that's a conclusion of a career. But for me, it's just a start. It has given me so much more energy than I've ever had. I didn't even know I had that energy in me to start new endeavors with intensity, unimaginable intensity. And it's all about science, about the discovery, about the thrill of discovery. I'm addicted to chemistry. Well, I think it's a complex relationship with society because the responsibility of a researcher is to advance the frontiers of knowledge, uninfluenced by other factors that may be around them, especially societal pressure to solve certain societal problems. I think we do much better when we are left alone to solve intellectual problems, because when you solve an intellectual problem, you open up so many avenues that would impact society in ways that are unimaginable. And so I emphasize always that in your research, you should solve a challenge, an intellectual challenge, intellectual problem, something that has challenged the field, is a long-standing challenge, a big problem, and not to be so influenced by what society might want you to do, okay? Because if you do a good job at developing, solving these intellectual problems, then they will lead to many different solutions that were unimaginable before. That's not to say that we as scientists don't have responsibility to society. We do have responsibility to take this knowledge and translate it into something that benefits society. Society pays for our research. We have the responsibility to take it back to society in different form that benefits society. When I started in chemistry, I set out to make beautiful things. That was my motivation. But after I made them, I was obligated as a scholar to think, well, what might these beautiful objects be good for? How can I use them to impact society? So I didn't set out to solve the climate problem. You know, as a child growing up in the desert, obviously water harvesting would have been wonderful to have, but we didn't have it. And you would have thought, well, that may have in a way motivated me to do science. That's not true. I was not motivated by problems that society faces. I was more motivated by the beauty of molecules and what I can do to create more beautiful objects on the molecular level. I think that's what attracted me. But once we made those, then we started thinking, well, how could these be used? How could this newfound power of manipulating matter on the atomic and molecular level be used to solve some of the biggest problems known in the world? Water, carbon capture, and other clean energy. These are the result of pushing the frontiers on the basic science level. It certainly does, and I think what even offers more hope is that anyone, anywhere, of any background can go into a lab and with the right preparation of mind could make a discovery that can lead to solving a big problem in society. I'm not saying it's easy. It requires dedication, it requires thoughtfulness, but anyone can do it. That's the power of science. Science transforms us and transforms society in ways that we do not anticipate before that experiment is done. So that's the power of the experiment. And that's what I encourage everyone to do, is to try the experiment, try something new, and do it. And after you do it, you have a chance to discover something. And that discovery may change the world. I think the life of a scientist, I think science is not a linear path. So I'll give you an example. I said that I grew up in an arid region, desert region, and my job as a child was to wait for the water to come from the city, because it came once a week or once every 2 weeks, and it came only for a few hours. So as soon as word was around the neighborhood that water is coming, well, I went to the faucet to open it and fill as many containers I can put my hands on within that specific period of time. To fill them with water, and that's the water that we had for that week or for those 2 weeks to use. So later on, fast forward from my childhood to 2014. Okay, in 2014, I looked at some of the data that my students were showing me of water uptake by moths. And that in itself was not truly novel, in the sense that measurements like that have been done for many, many years by moth chemists. But I saw in that data something that no one has seen before. And that's because of the background that I have. I saw that in fact this material could be used as a water harvesting material in the desert, because I grew up in the desert and I knew the conditions under which this material could potentially become a water harvesting, and it did. Okay, it did. So the question that I have, could I have seen that in that data without having grown up in the desert? And this brings me back to the people who do research from many different backgrounds, and that's why that creates an innovative system, a system of innovation, an ecosystem of innovation. The more mixing of scientists with different backgrounds, the more innovative that culture, that scientific culture will be. So my advice, if I was to pick one thing to advise young scholars, is to say you are capable of a discovery in research, in science. The only thing between you and that is the experiment. You need to try the experiment. You need to do the experiment. And that may lead to a discovery which may change the world. I think good scientists, first of all, ask big questions. And to solve those questions, you do experiments and you make rigorous observations. And you constantly ask yourself, why? Okay, science begins with doubt and questions. And I think that's very important in terms of digging deep into what you are doing. You should not just believe whatever you observe, but investigate and question, is it real? What makes it real? What alternative explanations might there be? So I think that's very important, the approach to doing science, and it helps you later as you do more and more experiments. You will realize that laboratory work is full of failures. Right? You think you're going to get something, you don't get it, but it's not a failure. It's an increment to success. It's an opportunity for you to learn about your system. So don't think of it as a failure, and that increments to success will lead to discoveries. So now I should mention, actually, this is I think important piece that I think would benefit many others. Even though I was in love with chemistry since I was a child, when I went to graduate school to do my PhD work, I often questioned myself whether this is the right kind of field that I want to spend the rest of my life doing. This is the kind of discipline that I want to participate and contribute to. Why? Because I was supposed to do a very simple reaction that I was not successful at. Trivial, almost trivial reaction, but I was not successful in doing. It took me a whole year to actually accomplish a very trivial task. That was the beginning of my graduate work, and during that year I questioned whether really is it in me to be a scientist, is it in me to be a chemist? And I think first the passion that you have for that discipline does help you, but also if you think of those so-called failures as increments to success, as opportunities to learn about your system, then it keeps you going, and just little by little. Okay, as you learn, eventually you arrive and you make that discovery. Well, I think the beginning of creativity is questioning your observation. Questioning, is what you're observing real or not? That's first. The second is to think different, to try to view what your observation, your data is telling you from a different angle. Always try to find an alternative explanation. And so that's just the beginning of creativity. I think ultimately, if you really want to be creative, you should answer questions that everybody says couldn't be done. I mean, I think that's how you identify really big questions and interesting questions, and things that others are not pursuing. Opening your own path, that's part of creativity. So ask yourself, what are people saying in the field that does not work? They keep saying it does not work. What is an article of faith that everybody is taking as that's going to behave in a certain way, and that's believed widely? Try to prove that otherwise. Okay, or that a certain scientific event is not going to take place because of certain long-standing difficulties. Well, those are the problems that are most worthy of scientific research, and I would definitely take those on. These discoveries, as I said, are not linear. Let me tell you about my discovery of MOFs. Well, I met this student when I was a visiting scholar in China back in 1989. And I spent about 40 days there in Nanjing University. And I met Halian. He was a student there. And when I became independent professor at Arizona State, he wrote me a letter and in that letter he said, I see that you're working on metal organics. I think I could do a better job than you. And so I thought, well, if somebody can do a better job than me, I certainly would want them to be in my group. And so I bring him in as a graduate student and so on. And he and I loved beautiful things. We loved crystals. He loved crystals. He would do reactions just to make the most beautiful crystals, where he did this reaction and he found these beautiful cubic crystals floating on the surface of the liquid. Okay, they looked like diamond. And he was absolutely fascinated by them. But then when he took those crystals off the liquid, they turned into this white powder. Okay, and to a student that looks very dramatic, and it looks like this material is not very interesting, it's not very stable. Well, I was observing that. Okay, I talk to my students quite frequently about what they're doing. Not too close, not too far. Just making sure you're close enough that you know what they're doing and you can ask intelligent questions about it. And I said, well, don't take it off the liquid. Analyze it in the liquid. And when we analyzed it and did the crystal structure of this beautiful crystal, well, it was MOF5. It's the very thing that the Nobel Committee cited. Well, at the time, we knew it was an amazing discovery, okay, because you have combined two fields of chemistry, organic and inorganic, into this MOF, and it broke all records of porosity. So not only was it a beautiful object, but clearly it had physical properties that were extraordinary. And so that led us to many different applications. So that moment, when we looked at the crystal structure, we looked at each other and said, there is something here that is very special. It's unforgettable. I think AI is a help. It's a great help to what we're doing. I think chemistry is a great field, but it's still living in the past. And what I mean by that is that we're the only scientists that can manipulate matter on the atomic and molecular level. That's extremely important. But we have not modernized our labs to be commensurate with how fast society is evolving. So I think chemists need to evolve with the time. We are not in danger of being replaced by anything, okay, by any other class of scientists, okay? We're in danger of becoming irrelevant unless we evolve to embrace the changes that society is going through, and that's AI. That's one of the examples where AI could help us in simplifying tasks in the lab, to making chemistry more sustainable, to increasing the rate of discoveries in our lab, in bringing talent into our lab. Okay? Students have to be excited about science, and AI helps us bridge that gap with the students so that chemistry is a modern science, and chemistry is a science that's keeping up with the time. Chemistry is a science that is moving at a commensurate rate that society is evolving. All these things help us strengthen chemistry and helps us draw in the smartest and brightest from among the young scholars. So AI is an example of a new tool that we need to be engaged in so that we can develop it in such a way that can serve chemistry to the maximum. And so a few years ago, I had a colleague in computer science, and she drew me in. She said, oh, you made all these MOFs, you made all these discoveries with MOFs. I think it's a very appealing area to blend in AI. Well, AI for science is just in its sort of beginnings. And I didn't know anything about computer science. I didn't know anything about machine learning or anything about these AI tools. But we didn't let that stop us. It was easier for us to jump in and start experimenting with it. And it has transformed my lab. Within the last 3 years, almost no one is doing chemistry in my lab the traditional way. Because now they can do things a lot faster, a lot better, more discoveries, using large language models, machine learning algorithms that have been adapted to chemistry. So this is transforming my lab in a big way. And I think it's very good all the way around. It's good for our young talent. It's good for chemistry, making it more current and more relevant. Well, the committee called me as I was landing in Frankfurt. I was on my way from San Francisco to Belgium, to Brussels. And they called me as I landed in Frankfurt, and yeah, I was just standing there in the aisle trying to get my luggage, and the door of the plane hasn't opened, and I was receiving the call right there. So it was quite something. Another thing that is unbelievable. It's like magic.